Bob Nagy, AB5N, back here with another equipment review. Today we really got a super interesting radio. Now, all of us are familiar with the radios from the three big Japanese manufacturers. I mean, no surprises there. We've been with them for years. And the two major American manufacturers, Elecraft and Flex, that are out there. But there are also some minor players in this game, some small manufacturers out there where you have or may have not heard of their products. And one of them today that we're going to talk about is Apache Labs and their Anon series of SDR radios. Originally, this radio was produced in India and in their what they call Silicon Valley of India, and designed by this small corps of engineers from around the globe. The software that runs on these radios most commonly is a version of Power SDR, HPSDR, which is an open source program which was used on the earlier Flex radios, but this is a highly modified version of that, customized for these Anon SDRs. And the current version is called Thetis, so that's what we're running right now, what they call Protocol 2. These radios have been around for quite a long time now, and the software and firmware is pretty well ironed out and very sophisticated. So let's take a look at the Anon 7000 DLE Mark II, the current offering. It does two things extremely well: receive and transmit. The 7000 DLE2 is a sleek-looking black box, about 3.5 inches tall, 10.5 inches wide, and 11 inches deep. It's got two good-looking handles on the front. It's got an RJ45 for your Ethernet connection, a mic input, headphone output, and CW key input. A little rocker switch on the right, and little power indicators on the bottom left. The rear of the box is filled with connectors. You've got a whole bunch of antenna connectors, three main ones, which I love. Then you've got your RX2 input for your diversity reception, your transverter input, and a couple of other connectors there. They're BNC, so you do have to use an adapter to 259 there. You've got left and right speaker connections and 6 RCA connectors, which is PTT in, out, and some audio connections. To the right is a DB9, which is interesting because you can set up different on-off states to control other hardware with different things that are happening in the radio. We've got a GPS DO clock input and transverter input. Of course, your ground connection, Anderson power pole for your power, which is reversed to the standard configuration, by the way, so you need a little adapter there. And you've got a fan DC voltage out if you want to add an additional fan to keep the unit even cooler. What's conspicuously missing is an ALC connector for your amplifier, but this radio, in concert with its software, can easily be set up to have a maximum power level which matches your amplifier perfectly. With the Mark II, they went to an improved heatsink configuration, and the fan for the unit is mounted on the bottom side of the radio. I'd like to stop for a second and talk about your most important connection to the 7000 DLE. Like the Flex radios, this has a gigabit Ethernet connection on it, and this is what connects directly to your PC or to your router, and then your PC can access it through the router. But all of the control is done through this CAT, audio, PTT, and everything else goes through this extremely high-speed connector, and that is a very good thing. Thetis and other software packages are going to use virtual audio cables to interface with other software you're running. And also for PTTing, you can use virtual COM ports, which are available as utilities free online. Now, for those of you who are new to SDR technology, I'm not going to break it down for you here, but look at my other videos. I've got some really good SDR primers in them. What is primary to know that DSP, digital signal processing, is used in an SDR, but it can also be used in a traditional superhet transceiver. I'm not going to show you every feature and function of the 7000 DLE Mark II. It would take 3 hours. I am going to show you what makes the 7000 DLE Mark II, in combination with the Thetis software, unique. I did want to mention that the radio comes in two flavors, the one you saw and this one, which has an integrated i7 computer in it, so it's really plug and play. First, let's take a look at this beautiful filter board over here. Count the relays, folks. Look at those nice sized toroids over there, so incoming signals going through those preselectors are not going to swamp these filters. Here's a little block diagram of the Altera Cyclone 4 FPGA. Now, what does this mean to us? What this means is this thing can crank out the MIPS, millions of instructions per second, processing our digital RF needs without breaking a sweat. This thing's using about 35% of its ultimate capabilities. There's a massive amount of horsepower under the hood in this radio. Now, we can talk about filter functions and all kind of stuff here, but boiled down, what you need to know is this. The tighter the filter skirts are, that ultimate selectivity, the longer it takes those chips to do the job. And the more processing that takes place in those chips, the longer the delay from RF on the air to AF coming out of your speaker. You want that latency to be short, and it takes great engineering to do that. You can always throw money at it by buying more expensive chips, but radio designers have a budget limit, so it takes really good engineering to pull it off. Using the Cyclone 4 FPGA chip has ensured there's enough horsepower to pull off extremely low latency times down to 20 milliseconds, and you're also given the choice of linear phase filters with a slight bit of more delay if you so choose. Now let's talk about diversity reception. Because this has dual phase synchronous ADCs, 2 phase synchronous reception channels, it's possible to do phase cancellation of local interference. And I'm not talking random background noise. I'm talking about interfering signals that have periodicity, that look like a signal. And as well, you can use multiple antennas and control the phase between them to enhance the incoming signal. And here's a demo of using the diversity reception to cancel a local generated noise. Here's a horrific noise here. So offending local noise can be completely eliminated in most cases, and that phase level adjustment you saw me do is good for about 200 kilohertz of bandwidth, so if you tune further away than that, you sort of have to retouch it up. Let's talk about noise blanker performance next. This is a big issue for us. This has 2 modes of normal blanking and a spectral noise blanker, and they are adjustable. So let's take a look. On noise blankers, normally when you kick them in and you can kill some of the noise, you do hear some distortion on the sideband, and I do not hear any distortion on this audio.
Lee, Lima Echo Echo, call sign November 0, Golf Foxtrot Victor. Back to you.
Another artifact I always hear is when you kick in the noise blanking, you can hear you can hear signals, nearby strong signals bleeding through. This doesn't happen as well. One of these noise blankers actually interpolates and creates the missing sound from the noise spikes that were removed from the audio, which results in distortion-free sound when using the blanker. Now let's talk about digital noise reduction, the most important one. And this is where these high-power radios really shine, or they're just average. Most digital noise reduction systems use what's called LMS, and it's an algorithm used for digital noise reduction. 7000 DLE has LMS in its first mode, but it has a second mode which is called spectral noise reduction, and this uses models of speech to determine its operation, and it results in the best digital noise reduction on the ham radio market today. There's one that's pretty close. It's the FTDX 101D, but they just updated their firmware, and the DNR is not as good as the original one. So let's take a listen to this one.
I didn't have your complete call the first time. Well, thanks for the nice report. And you're coming in here about a 5.7 to 5.8, very nice signal. So many stations on, the band is really packed, so I'm glad to see 10 meters open like this. We have a nice warm day here. It's in the upper 80s already. I'm planning to hit the golf course in about an hour and 40 minutes. So I'm going to have to queue up shortly and go have some lunch. But to see 10 meters really cooking like this, over.
So using all these noise mitigation tools, spectral digital noise reduction, which you just heard, a diversity phase noise cancellation, and an interpolating noise blanker, and it's in the top 10 list at Sherwood, it's a very hard combination to beat. And I'm just going to say it, it's the best receiver I've used in 48 years of hamming. And we haven't even talked about the transmitter yet. Now, you know I'm not a fanboy. I'm not in any brand's pocket. I like good radios. But I'm going to start sounding a little bit hyperbolic here, and I don't want to lose my credibility, but we all know Kenwood is the audio transmit king. I mean, they always have been. But I'm going to tell you, it may not be that way anymore. The transmitter in the 7000 is a direct conversion SDR. No surprises here, that's how it should be done. It does use an LDMOS driver device, that's unique and good, and it uses the industry standard Mitsubishi RD100 HHF finals. I love them. FTDX101D uses them. They're the industry choice right now, a nice device. But it is a 12-volt class device, and it does produce IMD products, distortion products. Of course, all transmitter chains do produce some IMD. What this thing has, though, is adaptive pre-distortion. I'm going to call it an IMD optimizer. They call it Pure Signal 2. So what we're talking about here is that the radio samples its output and pre-distorts the signal coming into the PA amplifier to compensate for that IMD, thus linearizing the amplifier way better than even a Class A transmitter. Companies out there have been saying they'd implement this for years, but Anand is the only one who has. So here's a classic two-tone test of the transmitter. And you can see the little Christmas tree stuff on the side, down about 30 dB. This is courtesy VK1HW. We kick on the pure signal, and bam, they're down 50 dB. A heck of a lot cleaner. Let's take a look at sideband. Here's a classic sideband transmission, stuff above and below that you don't want. Kick on the pure signal, adaptive pre-distortion, and down 55 dB. That is super clean. Now, although it's completely automated at this point, you just turn it on. The Pure Signal, and Pure Signal 2 it's called now, display screen looks like this, showing you the adaptive pre-distortion going on. So very, very interesting, and of course a great net effect. So clean is great, but what about audio quality? This is where it starts to get fun. Well, you've got at your disposal a whole selection of broadcast-grade power tools to make your audio sound fabulous. It has split-band pre- and post-compression, just like a broadcast audio processor. It has a regular TX equalizer, and you can set the frequency ranges on these things. Of course, it has a receive equalizer. It has noise gating, so it quiets in between each of your words. It has the leveler, which we'll describe, really punches up the clarity. It lets you control the overall gain and the decay of the AGC. That's really nice. It has a standard wideband compressor like we're all used to, a little audio compressor. It has unlimited TX profile memory, so set yourself up exactly what you want for, say, my 3 kHz setting, normal setting, save it with a name. You can set up all the profiles you want, call them up instantly. And it has the ability to take analog and USB digital microphones. So say you've got a USB headset and you want to use the microphone on the headset, no problem whatsoever. And of course it does ESSB, wide bandwidth SSB for the guys on 14178. Set it to whatever bandwidth transmit you want, save it as a memory, and you're ready to go. I almost forgot the phase rotation control, where you can linearize the amount of energy above and below the zero line.
Okay, this is Alpha Bravo 5 Nancy transmitting with a Elecraft MH3 hand microphone into a ICOM 7610 as the local receiver. 54321 12345.
12345 4321 Alpha Bravo 5 Nancy testing. Amplitude modulation, same hand microphone, same local receiver. AB5 Nancy 12345 and out. Well, there you go. My first attempt at setting up the audio correctly as a new operator. I'll probably walk it in quite a bit. You want to hear it done right? Look for NA1A, Duke, on 20 meters usually. He's running an Anand. He has it set up correctly. Oh my gosh. Then you'll hear what I'm talking about. As it stands right now, let's just take a look at the screen here. We've got the power button. We've got several menus up here for different things. We have turning on our second receiver over here. Just click on it, and we've got 2 of them like that. Click it off. I have a Bob's S-meter up here. It's a free utility to give you a nice analog-looking S-meter. Really nice. Got our volume controls here, master, and for each individual receiver. Automatic gain control, that's self-explanatory. Drive, which is transmitter power out. Our AC, AGC selections over here, including a custom one you can set up, and our attenuator. You can go steps of 1 dB, or you can do 10, 20, and 30. Squelch control for FM. Panning around over here, and it just allows you to move the display to the left, right, up, and down frequency. I don't use that much. I'll recenter it. We've got all of our VFO A and B controls like you'd find on a regular transceiver here, including RIT and XIT. Our virtual audio cables are selectable on and off down here. That's for when you're using the digital modes and you want to route audio to your outside programs. Here's all of our noise mitigation, you might call it. We got our noise reduction 1 and 2, the really awesome one. an automatic notch filter, noise blankers, several selections there, a spectral noise blanker, all kind of fun stuff to mess with to get the noise away and the signal up. Simple mute button, multiple notch filter, manual notch filter. Anyway, then because we have two speaker outputs in the back, you can control, have one receiver on one and one receiver on the other, and you can control their volumes individually or pan back and forth. So we can easily open up a second receiver and we can have a Panafold display or whatever we like on it, have them both showing. But also if you hit the multi-RX button, you can open up another receive frequency inside of that single receiver. So you can have a lot of receive options with this setup. C-Tune's a good button because it allows you, when you click it, to just move the actual passband around the visual screen as it stands. If you turn that off, well, you're doing the opposite and moving the background with the fixed passband in the center. You can have averaging on and off on the display really quickly, just sort of smooth it out here, or you can just show the peaks. Here's the microphone control area with your standard gain, your standard compressor, and then we have a look-ahead Vox. This is really unique. You're not going to drop syllables. This is actually a look-ahead Vox, and our DEXP, which is the noise gate. Zoom is zooming in and out on your spectral display, all the way from very tight to all the way in the full bandwidth that it can present at one time. We have our transmit profiles over here for selecting the different pre-selections you've set up. You can download all kind of ones, or you can make your own and put them in here. So I've got, wide, narrow, DX, all kind of things. And on the fly, you can adjust your low and high points on the transmit audio. Our equalizers for receive and transmit, we can turn on and off right from this place right here. This little button here is a TX filter. It allows you to see the actual width of the TX filter on top of the receive filter. So I do want to see if I'm transmitting and receiving at the same bandwidth. That's pretty easy to do there. Here's our pre-selections for jumping to different bandwidths in the mode that you're in, and each one has a different set of them, and each of these are individually configurable to whatever you like. Or you can just go ahead and slide the width over here and get your filter narrow or wider, or shift the center on like the old IF shift like that. Plus, as well, when you're just receiving, which is really great, you can go ahead and take your mouse and drag the filter around and change the filter width, and this is really nice to have as a feature. Some of them don't have this. Here's all your modes, including digital radio mondial, if there's still transmissions in that. You got your AM, sync AM, and the normal setup over here, and your band selections. What's nice about this is you can just hit WWV like this and go through the WWV frequencies, including the CHU Canada frequencies, which is sort of nice because I never can remember what those are. But that way you go through all the standard time clocks there. You can go from HF mode over to shortwave mode over here, and it'll have all of your shortwave bands, including broadcasts. And this receiver is pretty excellent on the very low frequencies. Doing that is a challenge for SDRs, so getting that right is a big step in the right direction. Most SDRs have difficulty at broadcast band and below. On our meter over here, our sort of a VOM, I think they actually call it, it's a multimeter they call it, you can choose all the stuff over here, ALC and forward reflected, mic EQ, and check all your levels. In the manual will tell you how to set up your mic and that kind of thing. And we can go for an averaged signal or the regular signal, or outputs of the ADCs themselves, left or right, one or two. We have two ADCs in here, or turn it off completely. And what's nice is when you just click on the top of this meter, it'll cycle through the three presets for, say, reception right now, which is you want an S meter, or you want it to show in dBm, or you want to show it in microvolts. That's pretty keen. Sometimes I'll leave it in S meter. Also, you have the option of showing and keeping the peaks in the last several seconds over here with a little meter underneath. Let's move the Bob meter down over here. We've got our two VFOs, A and B over here, and you can sync them up when you press this button. A lot of times you want to do that when you're doing diversity reception, something like that. But you have some other controls here, including your tuning steps, your band stacking registers, how many frequencies and such, and receive antenna control. So this is how I set it up most of the time. Your tuning ratio when you're dragging it around like this, it's going to be dependent on how zoomed in you are. Okay, because you're moving the same amount on the screen, but you're moving a lot more frequency. So it's variable, the tuning rate, along with how zoomed in you are. Now that said, for the tune steps up here, this is for your mouse wheel if you're using a controller like that. So a lot of times I'll get pretty close, and then I'll just say I'm going to pop right onto the 100 kilohertz even frequency if a guy's really rock solid right on an even frequency there using the mouse wheel. These I'm not going to go through each one up here, but you've got your receive and transmit equalizers, which are showing up on my other screen. There we go, like so. And your diversity reception, which you've already seen. That's pretty darn good. And some other stuff, what is really nice is not only can you record off of the air and save recordings and have your CQs and all that pre-canned, but you can do a recording on the fly of somebody coming in, record, and then play them back to themselves immediately and transmit that back on the air. That is a feature that 95% of radios do not have, and you have to go through all kind of gyrations or use your PC to be able to do it. It's really nice when you say, gee, you got a hum on your signal or something's going on. Here's what you sound like. The only other thing I didn't really mention here that's important is this PSA, and that's the pure signal 2, which will show up on the bottom side of the screen here. When you talk, it'll show calibrating, and if it's all green, you're good. So that's the ultra-pure transmission technology that works in the Theta software in concert with the Annin radio. This display is infinitely customizable to exactly the colors, the buttons, the kind of things that you like. You can use pre-canned skins that are there, or you can download ones that are on the internet, and then you can modify those. So I changed the background to blue, and I liked a little bit of a mustard color on the trace over there. So I wanted buttons that would sort of look like they were popping out. So it's very easy to implement this kind of stuff, and there's tons of information out there on doing just that. So that's the basic runaround here on the screen itself. Like I said, tons of stuff to discover, super customizable. The software is robust and ironed out to where I haven't had really any problems with it whatsoever. In the old days, it would bomb and all kind of things like that, early SDR software. You're getting into this now. You're in late in the game. So the people before you have trudged through the mud for you. So you're about to jump into a thing that's very well polished at this point. So in conclusion, yeah, this is not a box with knobs. You know, we all have boxes with knobs, probably more than one of them in the shack. We're used to them. You know, you can put a tuning knob on this radio, but I can tell you, I did put it on there. I can tell you, I didn't use it after a while. Once I got used to the way this thing QSYs around and everything, I didn't miss it, and it was no real help. This box is sort of like an RF laboratory because you are using the most sophisticated digital signal processing tools to carve signals out of the background. And that spectral display, that is second to none in the industry. It is as good as it gets. It is also supported by a large group of users, and you have a lot of interactivity. I interact daily with people on the forums here, on the Annin forums. I put out questions. Well, does it do this? How do you do this? And people are constantly bouncing around giving feedback, and of course the developers are on there as well. Now, getting into this now, after so many years, this software and firmware is very sophisticated, mature, stable, and you're not an early adopter by any means. 10, 15, 20 years ago, we were early adopters. I pulled out most of my hair getting the early SDRs going, getting them stable. We're not at that point now. This thing, if nothing else happened to this radio, you would have a super sophisticated, capable, reliable radio that does everything fantastic right now if there was no more development. But that's not what's going to happen. There's going to be development with this radio. It's only using about 35% of its horsepower. A lot of great things could happen, and many things are going to happen. So it's a safe time to jump in. I'm going to give this radio 2.5 thumbs up. I don't know if I can do that here. Really, this is pure radio excitement, folks. This is why I'm in it. High-tech, cutting edge, and I think you'd have a lot of fun with this radio. So until next time, take care.